Find the exact value of the expression and it's sine 330 times cosine 30.
Times?
Yeah.
Okay.
All of that minus cosine 330 times sine 30.
Well, notice that this is the same, and this is probably the way they want you to do it. I mean, obviously you could plug that into a calculator or figure out what each one was, but I suspect what they want you to do is this, using your sum and difference. And that is the sine of difference. So that's the same as the sine of 300, which is the same as the sine of 60, which is root 3 over 2. It's in the fourth quadrant, so it's negative.
Oh, so that's the answer to all that?
Yeah, if I did it the hard way, this would be 1/2. This is root 3 over 2. This is positive root 3 over 2. And this is 1/2. So we would have root 3 over 4 minus root 3 over 4. Hold on.
Okay.
It's got to be double minuses. Sine is negative first quadrant, or in the fourth quadrant. So it's minus root 3 over 4 minus root 3 over 4, which is minus 2 root 3 over 4, which is my answer. Minus root 3 over 2.
Oh, okay.
Okay, so it does work out, but it's clear since you're in the sum and difference section of trig that they probably want you to do it this way.
Well, our teacher has been asking us to do it the hard way.
Really? Just by figuring out each one and solving it?
Yeah, I didn't know it was that simple.
Well, that doesn't teach you much about sum and difference, whereas this method shows you that there's a shortcut by using the sum and difference angle.
Yeah. So could we do cosine pi over 4, or cosine of pi over 4 plus pi over 3? And I guess expand that and solve.
Yeah. Well, I can do it two ways. I can add the two angles so that I have 7 pi over 12 and answer it directly. But in this case, I suspect they want you to do it the long way.
Yeah.
And what's the rest of it?
Going to be minus
Yeah, it's always opposite.
sine, yeah.
And both of them have 2 sines and 2 cosines in there. In other words, the sine sum and difference is sine, cosine, sine, cosine. So there's 2 of each in both of these. So that's root 2 over 2. That's 1/2 minus root 2 over 2 times root 3 over 2. So we have root 2 over 4 minus root 6 over 4. And that you could factor out the fourth and have root 2 minus root 6. Which is interesting, because if I do it direct and take the cosine of 7 pi over 12, oh, I don't know how to do that. Yeah, I would get I would get a decimal answer,
Mm-hmm.
but I wouldn't get a radical answer.
Yeah.
Whereas when you use the sum and difference formula, you get radicals in your answer.
Mm-hmm.
I might get a radical answer if I use the half angle formula, I suppose. In other words, that would be 7 pi over 6 divided by 2. And then I know what 7 pi over 6 is. So lots of ways to do these problems.
All right. All right. How about sine of pi over 12 times cosine pi over 4 plus cosine pi over 12 sine pi over 4.
Now notice on this one, we don't know what sine of pi over 12 is. So this would be hard to do in the standard way.
Mm-hmm.
But much easier to do using the plus or minus. So what is this equal to? It's clearly a sine plus or minus, and it's a sine plus. Add those two, you get 4 pi over 12, or pi over 3.
Okay.
You saw how I added those two angles?
Yeah.
Okay.
And here's one with tangents.
Okay.
It's tangent of 25 plus tangent of 110.
In parentheses, all of it?
Yeah.
In other words, is it the tangent of 25 plus 110, or is it the tangent of 25 plus the tangent of 110?
Oh, no, it's the tangent of 25 plus the tangent of 110.
Okay. Which is different. That is different. Okay.
Over 1 minus tangent 25 times tangent 110.
Notice that that is the sum or difference of tangent. So that is going to be the tangent of, and this is the matching sign, I believe. The bottom one is the one that's the opposite.
Yeah.
So it's tangent of 25 plus 110, which is the tangent of 135, which is what?
I'm not sure.
Let's go through how we get it. Second quadrant?
Mm-hmm.
What's the equivalent first quadrant angle? Or excuse me, I meant to write 180.
It's going to be 45.
Correct. What's the tangent of 45?
Root 2 over 2.
No, that's the sine and cosine of 45. If you draw your,
one.
It's just 1, okay? But it's in second quadrant, so it's minus 1.
Mm-hmm.
Okay.
All right, so this is given that sine of u equals 5 over 13, and cosine of v equals negative 3/5, and both u and v are in quadrant 2. It says find the exact value of the trigonomic function, and it's sine of u plus v.
Okay. Let's use our identity.
So it's going to be sine. So
Sine of u cosine v plus sine of v cosine of u. Okay. Sine of u we know. 5/13, second quadrant, positive. Cosine of v we don't know it. Oh, yes we do. Minus 3/5. Sine of v we don't know yet.
Yeah.
So given that the cosine of v is minus 3/5, how do we figure out sine of v?
You make a triangle and solve for the other side.
Label v. If the cosine of v is 3/5, then that's 4. And the sine of v has to be 4/5, only it's positive. And then the cosine of u is a similar process. We know that the sine of u is 5/13. That makes that 12. That makes the cosine of u 12/13, but it's negative because it's second quadrant. Minus 15/65 plus minus 48/65, or minus 63/65.
Okay. And then another one similar to that. Cosine of same thing, u plus v.
We have some values.
It's the same values.
Oh.
So sine of u equals 5/13, and cosine of v equals negative 3/5.
Okay. So what's the formula here? What's the general formula?
Cosine cosine u, cosine v, plus, or no, minus sine u, sine v.
Okay. Same quadrant, quadrant 2.
Yeah.
So the cosine of u we figured out was 12/13 minus. Cosine of v is minus 3/5. Sine of u is 5/13. And the sine of v we figured out was positive 4/5. Now we have 36/65 minus 20/65, 16/65 positive.
Alright. So it says find all solutions of the equation in the interval 0 to 2 pi. So this is kind of using this and also the solving earlier. So sine of x plus pi/3
like that?
Yes.
Okay.
And plus the sine of x minus pi/3
Okay.
equals 1.
Equals 1?
Yeah.
Okay. Let's use our formulas to translate each one of these.
It's going to be sine x cosine pi/3 plus cosine x.
I like to keep the order the same, just I can remember it easier that way.
Okay.
Like that, rather than switching the order.
Yeah.
I mean, it doesn't matter, but we all have our little tricks for So this one is what? Same thing with a different sign. Okay? So if we take out the parentheses, we don't need them anyway because we're adding. You will notice we have a term there that cancels with that term. And we have two of these. So we have 2 sine x cosine pi over 3. Cosine of pi over 3 is what?
1/2.
Which cancels out that. So now I have sine x equals 1. And we're looking for all solutions between 0 and 2 pi. Well, in this case, that's only one solution. What is it? Where's the sine equal to 1?
Sine's equal to 1 at pi over 2.
And that's the only place. Most of these would always have 2 answers because there'll be 2 quadrants. The only ones that have 1 answer only are some of the quadrangles. Not all of them. If I said sine of x equals 0, well, that has 2 solutions, 0 and pi. But when it's 1 or minus 1, you're only going to find one solution.
Okay. Just another one similar to that one. Cosine of x plus pi over 4 minus cosine x minus pi over 4.
This one we got to be a little careful with the parentheses because we're subtracting. Okay, let's translate this.
That's equal to 1.
The whole thing is, sorry.
Yeah.
Okay. So this becomes what? The first one.
It's going to be cosine x minus...
Hold on.
Times cosine pi over 4.
Okay.
Minus sine x times sine pi over 4.
Okay. Minus this one. Same thing, opposite, right?
Yeah.
Okay, so let's see. Now when we remove the second set of parentheses, we have to change that to a minus. And I can still remove the first set of parentheses without doing anything. Now do we have anything that disappears? Yeah. This term and that term cancel. And then what we have is 2 of those, minus 2 of those. The sine of pi over 4 is what?
Root 2 over 2.
So now we have the sine of x equals minus 1 over root 2. What's x equal to?
X is equal to pi over 6.
That's the same as root 2 over 2.
Oh, right. So it's going to be pi over 4.
Only it's going to be minus. And that's the way your calculator will give it to you. In other words, I could have said 7 pi over 4.
Yeah.
But if you put this into the calculator, in other words, if you do the inverse sine of minus 1 over root 2, it's going to give you a negative angle, always.
Mm-hmm.
And where else? Since we're in the unit circle, there's going to be another quadrant where we're going to have a pi over 4. So which quadrant is sine going to be negative in with that pi over 4 angle?
3. It's going to be
Yes.
5 pi over 4.
So 5 pi over 4. So those are actually the two solutions. You could also say 5 pi over 4 and 7 pi over 4. But I suspect, and I don't think you'd lose points, because 7 pi over 4 is the same reference angle as pi over 4, as minus pi over 4.
Yeah.
Whether it's the same angle or not, I don't know. I guess that's an argument left for mathematicians. But it certainly has all the same trig functions.
Yeah.
So there would need to be a comma in there.
Okay. It just says verify the identity.
Okay?
It's sine of, in parentheses, 3 pi minus 6 equals sine of x. It's 3 pi minus x.
Minus x?
Yeah.
Okay? If you take the sine of any angle, and you add pi to it, you get the same number, 1/2, only with a negative sign in front of it. Same thing with cosine. If I take the cosine of pi over 4 plus pi, well, the cosine of pi over 4 is positive root 2 over 2. The fact that I've added pi means it's going to turn negative.
Yeah.
Just like if I added 2 pi, then it would be the same. Or if I added 4 pi, it would be the same. So if you just add half of a cycle, all you do is change the sign. And this only applies to sine and cosine and their reciprocals. Tangent, if you add pi to the angle, you get the same thing. Because the period of tangent is pi.
Yeah.
Whereas the period of sine and cosine is 2 pi. So if you only add pi, all you're doing is going to put it from first quadrant to third quadrant or second quadrant to fourth quadrant. In either case, it changes the sign on the result. So, that being the case, first of all, what is the sine of minus x equal to?
Isn't that just negative sign?
Okay, so knowing that, we need to turn this left side into well, the sine of 3 pi I can certainly take out a 2 pi. You see that? So this is the same as this, which is the same as right?
Yeah.
Okay, and this means we're going to get the same number opposite sign. So that's the same as minus minus. And that's how you get that.
So
probably a few different ways to do this. Given what section you're in, he may want you to do this using the sum and difference formulas. Let's do it using the sum and difference formulas.
Okay.
I don't mind the way I just did it, but a little confusing. Well, sine of 3 pi is what?
0.
Takes out that term. Cosine of 3 pi is what?
-1.
So we have minus sine of x times -1, which gives us that. Because the sine, yeah, it gives us that directly. Yeah.
Okay. It's easier.
That was a better way to do it, actually. It was faster, even. But definitely less confusing.
Yeah, this one's a little bit more difficult. It's sine of pi over x plus x equals 1/2, and then in parentheses cosine x plus √3 sine x.
Okay, let's use our sum and difference on that. Let me think about this for a second. Well, I can't think of anything else to do, so let's use our so that's the left side. Oh man, this is one of those problems. I know this problem. This is one of the most difficult problems in trig. You have to really think out of the box here. I'm trying to remember how I haven't done one of these in like 2.5 years. I only get them about every 2.5 years.
Jeez.
Let me think for a second. I distribute that, half, that. Now, notice what the right side is. Let's look at the right side for just a moment. The right side is the same as the cosine. 1/2 could be the cosine of pi over 3 times cosine of x. And √3/2, let's see, do I want to make this sine cosine, sine cosine, or cosine cosine sine sine? Well, let's see, that would be the sine of pi over 3 times the sine of x. Is that helping? No, the left side has everything sine cosine sine cosine. So instead of making this cosine of pi over 3, let's make it sine of pi over 6. You see what I'm doing here?
Yeah.
And then I'm going to make this cosine of pi over 6. So this equals that. Now, how does it equal this? You sure this was pi over x, or was it pi over 6?
It is... Oh, it's pi over 6.
Much easier. I was bothered by that. I
Okay.
wasn't sure I knew how to do the other way. But now, in other words, I used the sum and difference on that to get this.
Mm-hmm.
And I used the fact that 1/2 is equal to the sine of pi over 6, and root 3 over 2 is equal to the cosine of pi over 6. And now I have this identity equals this identity.
Okay.
That's the tricky part, is turning this into a sine cosine plus cosine sine.
Mm-hmm. I don't really have anything else. That's all that was
Okay,
on our homework.
that's fine. That actually works out better for me. I was going to
Okay.
end up working extra late tonight because of that. Now I can get over there a little earlier for my next appointment.
Mm-hmm. All right.
So you're good with 30 minutes?
Yeah, that's great.
Sounds good. Talk to you next time, Griffin.
Thank you.
Bye-bye.